Today I'm showing how to use FluidNC with ESP32 and Fusion for CNC Plasma cutter. I've seen a few online, but nothing exactly that seems to follow the processes I use, so I was going to go ahead and show how we do that. The first thing I'll show is the use of the FluidNC board. I'm specifically using a 6-channel external driver board. Once you have it powered up, you can go to the Wi-Fi that it creates and connect, and it'll connect to the unit. And as far as controls, you can see here you've got your jogging. It tells you the distance that it'll jog for your X, Y, and Z. You've also got your homing. You can home the individual axis, or you can home all 3 axes. And it will do this according to how your configuration is programmed, so we'll go over that too. So once it's homed, then to establish your work coordinates, you would 0 it here, the X0, Y0, Z0. And you can work from there. You can set your jogging speed here for the X and Y, also the jogging speed for the Z, if you want it to go slower or faster. Next, in the durable section, you can designate what type of information you want to read and how often. In your, it'll read out in your commands window down here. You can have some speed overrides, some spindle commands, but that's only if you have a spindle attached. Most of this information wouldn't really use for running a plasma cutter. Some things you would use is right here it shows you the status of how it's running. Right now it's idle. It'll show running, alarm, and then to actually acknowledge an alarm, you click it right here as well. And then this is for a soft reset here. The next window is your files. It goes directly to your SD card that is on board with your ESP. You can see the files in here. It tells you how much space is left. And to upload a file, you can do it directly from whatever device you're using. Uploads the code and it's there. And from here you would execute your G files as well, and rename it if you need to, make any alterations. And the last window here is your commands window. It tells you what's going on at the current time, as well as you can send commands such as G0, so that's move full speed, X, whatever location you wanted it, Y, whatever location you wanted, etc. On the next tab from the dashboard, the FluidNC button, you can see the settings. In these settings, you designate which configuration file you want to use. You can actually have several configuration files on here and switch whichever one you're using depending on if a laser set up on there or a router, spindle, something else. You could have it ready to swap in between. This also has a lot of the Wi-Fi settings. You can change your Wi-Fi mode if you're just directly connecting to the ESP32. You can just make it an access point or leave it as it is. It's good for, from what I've noticed, within a cabinet, maybe 15-20 feet away is no problem to pass files and commands back and forth. Once you get a little bit farther than that, and lose control. So what you can do is you can go, if you have a Wi-Fi in the local area, you can connect through that Wi-Fi, extend your range. The other button here is configuration items. So this is looking at the configuration file that you've designated before and a lot of the settings in it. I'll go over these settings a little bit more in detail later. But you can change them within the program if you want to, if you just figure out it's going the wrong way or want to change the speed. Also here you have the system status. It shows the status of your ESP32. Managing your local files. So this is the files that are actually on the ESP, not on the memory card. You've got our interface that we're looking at, this Web UI. This is version 2, Web UI 2. You can also use Web UI 3, but I find it not to work as well with the Plasma CNC setup. Some of the commands just kind of get in the way. It's got an icon in there, and then it holds our configuration file. And from here you can download it, you can delete it, you can change the name, you can upload new files as you want. So you could have this like version 6, you could have version 7 in there that you want to switch or try out. You can update the firmware, you can restart it. This is actually pretty useful for if you end up getting it locked up or it's just not quite acting right. You can reboot it here, and then this will just refresh the settings. You can ensure that they've taken after you set it. The next view is a tablet. So this has all the basic commands you would use while you're using it. It's kind of a nice view. If you were to have a tablet with this running on it, you could have it, or your phone, right near the system, and be able to do all your controlling, jogging. That's what I like about this app, is anything with Wi-Fi, control and get the exact same commands. And if you do load a G-code file, such as this, if I was to run it, it's going to try and run it, and well, it is running it, although it's not actually connected. In the tablet view, it does show you the passes that it's making, where it's going. Some people like this, be able to see a visual of what's happening. Alright, that's about it for the FluidNC Web UI interface. If we were to look at the actual file, it's basically just a text file with all your information. Going through it, looking at your axes, your steps per millimeter is based on the motor you're using, if you're using a belt or just your gearing. So you have to figure that out. You have to either know what you're using, or you have to measure it and get an idea for how many steps per millimeter that you're running. Max rate, setting your maximum speed that you'll allow it to go. I've noticed sometimes with these, if you get over a certain speed, it'll start rattling or might even want to seize up. So you have to establish what speed you're going to allow it to get to. Acceleration, maximum travel is based on the size of your table. So from your homing point, this is how far you allow it to go the other direction, and it creates a soft limit, and you have the soft limit set here that it won't allow it to go there. When you execute the G code, it also looks at the distances it'll travel, and it won't let you continue through the G code if it's going to go past your soft limits. This is during its homing cycle. You can designate the steps that it cycles through. So this is number 2. So when I hit homing, it's going to home Z first, and then it will home the X, and then it will home the Y. And you can have any one of these home at the same time if you just give them the same cycle number. So if X and Y were both cycle 2, those would both start going to their limit switches at the same time after Z executed its. So depending on how you want to run it, a lot of times you'll sequence them, that way it doesn't run into something on the table. You can choose the direction that it homes here. If you have your limit switches on one side, the table the other, you might have to switch that around. While it's homing, it'll search the limit switch with this speed, it finds it, and then it backs off and comes back at it again at a slower speed to establish it at a little bit finer resolution. And with the motor, this is the pin I've got driving the X-axis driver. Once it gets to the homing point, I have it back off 10 millimeters. And again, with the stepper, you can change the direction that it runs through this toggle here. And it's basically the same for all the axes. On my table, I have a Z material height proximity switch. So that's going to pin 26. When you first turn it on, you can tell it if you want it to home right away or if you want to manually home it. The relay output, which actually turns the plasma machine on and off. Status outputs, you can have outputs for multiple different statuses. The only one I'm using is the alarm status. On mine, that just goes to a red light to indicate that there's some sort of problem. Some of these other things I'm not using. The feed hold pin is what I have tied to my e-stop button. E-stop generally would kill all the power, but then at that point you can't continue what you're cutting. So I use the feed hold pin. It usually immediately throws it into hold, and then you might be able to fix what the problem is. Maybe a tip up or something is in the way. You can fix the problem and then continue cutting, so you don't have to scrap that piece of material, hopefully. And then the macros, there's several different macros you can run. One of the macros I use is after it homes, it automatically move the gantry out of the way without getting in the way of my material. That's the basics of the configuration file. Fusion 360 is just a little bracket cut out. First thing you'll need to go is to manufacturer to cut it. And first thing you do would be to run a setup. So when you click the setup button, you would pick the operation as cutting. You don't have to have a machine designated for all these DIY machines. It's not worth building a machine out for it. Model orientation. For myself, I always run the Z and X axis. I find it easiest. For Z, you can actually just click on the flat surface if you want, or any line that's pointing in that direction. And then for the X, I'll pick another flat side or a line. And then I will usually designate my stock box point on the top corner of wherever I'm working. As far as the stock, it initially comes up with relative mode for me. So usually I always leave the top at 0. The sides doesn't really matter. If you want to give yourself a little bit of extra, you could put something in there just to ensure that you're a little farther from the edge, but I usually just change them all to 0. That way I know exactly that's where my point is going to start cutting from. And then also I know the size of my material that it's going to use. As far as the post-processor, you name it whatever you want. Comment, doesn't really matter. Sometimes I'll put the size of my material here. That way it's easier to reference. And the WC offset, you have to put 1. It comes up as 0 and it won't post it if you have it at 0. You have to put that to 1. So then the action you want to take is cutting. When you go to there, you'll have to pick a tool, and you'll have to make a tool designed around what you've got on your own table. So you can just name it any name. I run everything in millimeters. It's just easier for the items I'm making. The math is easier. It goes a lot quicker for me. The nozzle diameter is actually what you measure it, so it'll ensure that you're not bumping into things or hitting things. The kerf width. You're going to have to fool around with yours and see what it is, but from what I've found, 1.4 is pretty close to the width of the kerf for my cutting head. I'm using a IPM 60 pencil torch head. Holder doesn't matter, it's just going to be the way it looks in your graphics. The cutting data, this is the default speed you'll run. I'm running 1,000. A lot of guys are running about 1,300 millimeters per minute. The cut height and the pierce height, this will come into play when you're setting your linking as to where it will come in. So we'll look at this later because sometimes this might be a little bit big for what you're cutting out. These items here don't do anything. It's not automatic. So after you've got your tool selected, it puts the default speed in here for that tool. You can change that how you want, you can tune it yourself, see what works best on your table. As far as selection, if I'm going to try and cut everything in one pass, I'll just select the entire face and it'll pick all of the contours when you go to cut them. One thing I've found is that if you have some really fine work, it might not be able to cut it with your settings. So you can either let it error out over here and it'll miss those cuts and you can redo another one with different settings, or you can individually select your contours. So with Control-Alt you can select individual contours, but on a surface where you have a lot of cuts it can take a lot of time. So often what I'll do is I will create the cut profile for the whole thing and then look at it afterwards and see where it failed, and then I'll just create a second cut profile with some different settings, and I'll show you the reason for that. So I've got the contour. My heights, for mine, the top height I always put 0.1. 0.0 for some reason has caused some problems. So 0.1 always works. I always use that. Retract height for my specific table, I use 5 and 5. It gets high enough to avoid most tip overs and most problems, but it's not so high that it really slows down the process. It's high enough that it can retract and move on, and still keeps the cutting pretty speedy. Tolerance, I'll either run the tolerance at 0.01 millimeter or 0.001. Sideways compensation is always left. Compensation type, always in computer. Finish overlapping 0 millimeters. Roll around but never change the corner mode. Uncheck preserve. I will always check smoothing. The reason for that is it makes the G code much smaller. And what I found with this ESP32, if you have a pretty detailed cut file, the G code can kind of bog down the processor, and I've had it pause in between. It does some weird stuff. So smoothing seems to always simplify the G code enough that it doesn't have any problems. I never use stock to leave for this or feed optimization. Now in the linking, there's some things. The keep nozzle down, I uncheck that. Some people like to use that. I've found that it works better without it. Always use the lead in, always at 90 degree, radius 0, and the distance, I try and do 5 if I can. So this is where I was talking about, I'll pick the whole surface and I'll run it with 5. The reason is, if it can start the cut 5 millimeters away from a surface, then you won't see where it has cut in. If you have it closer, that sometimes you will, but sometimes the area that you're cutting out is just too fine of detail and you have to drop it all the way down to 2 millimeters, 1 millimeter. But in that case, you will see a little round where it is cut in and started doing the cut. But you don't want that on all yours, so that's why I'll do a cut like this. I'll show you an exaggerated view. So I'll say let's do 10 millimeters. Same lead out, same lead in. And the piercing clearance, 1.4 millimeters. I always leave that at that height. That seems to work good for when my machine's making the pierce. Okay, so if I hit 10 millimeters, tell it to go, you can see that the blue line, it is cutting the outside, but it's not cutting these inside ones. You can see in this the simulation as well. It's going to get those outside, it's not going to get the inside ones. And then it'll show you an error here. Toolpath, one or more passes were discarded due to limit linking constraints. And of course, this is kind of an exaggerated illustration of it, but you'll have that happen sometimes on some of your more fine or smaller cuts. You might have to go all the way down to 1 or 2 millimeters, and when you do that, then it'll include those smaller ones. So like I said, what I'll do is, if I have one where it doesn't cut it, I will just leave that. I won't fix that main one, because I know that it's going to be a nice far enough away cut that it's not going to hit those. And again, 5 millimeters is a good one that I see. So when it comes in, it's going to come in 5 millimeters away, go into the material and cut it. But to get these smaller cuts, I will just duplicate it, go back into the duplicated one, and then I'll reduce it down to 1. Actually, you don't really want to redo those cuts, because you're going to heat up the material, you're going to probably burn it. So I'll undo it, and I will just pick the ones that it wasn't able to get before, and then use your smaller lead in and it'll get it. But you'll see that it is much closer to the edge, so you will get a cutout in this material. Alright, and as far as the post-processor, I'm using my own version. It's just a version of Open Build's Fusion 360 processor. I've been slowly removing some of the things. That post-processor really is kind of designed for lasers and routers. Since I'm just using this for plasma cutting, I've made my own version of it. The name will just transfer over from whatever you've picked in your setup, but you can rename it here if you want. Save it to whatever file. As far as the post properties, a lot of these don't apply. So it's talking about the spindle, but the one item in here you'll worry about is the plasma on-off delay. So this is actually how long it will pierce, and then it will wait this amount of time before initiating the cut. So it gives it enough time to pierce through all of your material. If you're finding that you're cutting a thicker material and it starts moving before it's actually pierced all the way through, you might have to increase the timing here. For the material I've been cutting, 0.6 seconds is enough time to pierce through the material and be ready to keep moving. Start and end coordinates. I don't use this, but if you want to set a G53 point, you can have it add it to your job to move it to a place off the table. It's useful, but I haven't been using it too much. I've messed with it a few times and used it, but sometimes I like to rerun the job, and so I don't. If you don't set anything here, when it's done with the cut, it will return back to 0. And in that case, you can restart it immediately if you want, and then it'll go back and cut. And what I've found is sometimes I'll forget to put the ground connection on or something stupid, and so my first few cuts aren't very good, so I will rerun it again. So it's just something I do and something to think of. I keep this checked, linearized small arcs. Hopefully it makes the G code a little bit smaller. This laser power, none of these things do anything except for this, the touch probe offset. So when it goes and touches the material, from when it hits your limit switch and then it starts reversing the z-axis, and from the point that it starts picking up the torch again is this distance. So this is basically how you have set up your z-axis and the length of your probe. So you'll have to measure this and see what it is and adjust for it. This will change where your cutting height ends up being. I like to run my cut height at about 1 millimeter up from the material. So I messed around with this setting to see where it could be perfectly at 1 millimeter off the material once it's cutting. So this has to do with it touching down to the material and then coming and raising back up. And when you do this within the actual G-code operation, it will touch down, it'll raise it up to above that to 5 millimeters or so, whatever, and then it will come down to the cut height, because based on this reading. And then the machine settings are just naming convention that you might want to put in there. Built in also, I leave it at the default settings, and those work good for me. And then post it. And again, once you post it, you can just take it and immediately drop it into the SD card on the ESP32 and run it from there, connecting either with your computer, your phone, all through the Wi-Fi connection. Alright, I'm definitely not a professional at using this software, but this is how I use it. Should be enough information to help somebody using a similar setup. So happy cutting, and post any questions if you have them. I'll try and answer it.